Real.
We learn science, technology, and engineering.
We were talking about space.
We learn technology, art, and we build stuff that's very cool, so we can learn how to help the earth.
We build something that can protect us from the wind, from the rain.
We engineer, we build houses, we build other stuff that nobody else can on their own.
So we can learn science, technology, and build stuff that we didn't know how to build.
STEAM! We are the builders! Evaporation, condensation, precipitation. This is about designing and testing a water desalination plant. Following the science of water cycle, we use a thermal process approach to design, build, and test a small-scale desalination plant that is capable of significantly removing the salt content from a saltwater solution.
The thermal desalination approach involves heating the salt water until it evaporates, and then forcing the evaporated water to condense. The condensed water is clean water.
This type of process is used to produce more than 85% of the desalinated water in the world. This approach mimics the water cycle. In fact, each step in the thermal process can be linked to the stage of the water cycle.
Environmental engineers work with other types of engineers to design and install water desalination plants around the world as the demand for clean water increases.
In this project, we designed insulated beverages bottles with the challenge to test them to determine which materials work best at insulating hot water to keep it warm as long as possible.
The development of insulated vessels is important in engineering, especially in the fields of mechanical, chemical, and biological engineering. What we can learn about the design and construction of insulated beverage containers can be applied to the design of insulation for houses, clothing, and appliances such as refrigerators and ovens.
We also analyze data from tests to determine similarities and differences among several design solutions to identify the best characteristics of each that can be combined into a new solution to better meet their criteria for success.
In this project, we are building and testing wind-powered cars. We follow the steps of the engineering design process to create small wind-powered sail cars that convert the wind's kinetic energy to kinetic energy that moves the wind cars.
We applied our understandings of physics to design highly efficient wind turbines to make wind energy a viable source of renewable energy. Here's our design for one of our cars, and we're going to show you how this could become our car of the future. So this is our wind-powered car.
We create a hydrofluoric garden. We explore the science of environment, ecosystem, energy flowing, and organisms interaction to create a scale model biodome.
Every day, engineers adapt to existing designs for housing, structures, and cities, so they work optimally in specific environments and ecosystems.
To do this, engineering applies their understanding to specific environments, biosphere, along with concept of ecosystem to the design, shaped to be human-built environments.
Here they are.
Cooler design. In this project, we follow the engineering design process to design and build a small insulated box with the goal of keeping ice cubes and ice cream from melting.
We follow and apply concepts in thermodynamics and energy, mainly convection, conduction, and radiation to solve this challenge.
These are the coolers we have designed and tested. Steamy needs help.
In this project, we are tasked with the challenge to build an assistive device to help motivate a fictional baby to stand up and walk. By working on this challenge, we further our understanding of the engineering design process while being introduced to assistive technology, devices, and biomedical engineering.
One specialty of biomedical engineering is designing and creating new and better prostheses, replacement body parts. Biomedical engineers are continually improving the strength, durability, longevity, and lifelikeness so amputees and physical disabled can live full lives. Here are our baby Steamy walkers.
In this project, we create tetrahedral kites capable of flying. From our science lessons on gravity, we are designing a tetrahedron to use wind energy to combat gravity and create lift.
We explore different tetrahedron kite designs, learn the geometry of the tetrahedron shape lends itself well to kites and wings because of its advantageous strength to wind ratio.
We design our own kites by using drinking straws, string, lightweight paper or plastic, and tape or glue.
We experience the full engineering design cycle as we are aeronautical engineers. We determine the project constraints, research the problem, brainstorm ideas, select a promising design, and build a prototype. Then we test and redesign to achieve a successful flying kite.
It's about building something of value out of trash. This activity addresses the importance of reuse and encourages us to look at ways you can reuse items we would otherwise throw away.
We follow the engineering design process to create a useful product of our choice out of recyclable items and trash. We collected reusable items such as aluminum cans, cardboard, paper, juice boxes, chip bags, egg cartons, milk cartons, etc. from our homes to build this toilet seat.
Engineering plays an important role in our environment. Our landfills are filling up faster and faster, and pollution levels are getting higher and higher.
Designing projects from a global perspective includes low energy manufacturing, renewable resources, and utilizing recyclable and reusable materials is critical to decrease our pollution levels for a cleaner, healthier planet.
Airdrop system. In this project, we design and build devices to protect and accurately deliver dropped eggs. The device and the contents represent care packages that must be safely delivered to people in a disaster area with no road access.
Similar to engineering design teams, we design our devices using a number of requirements and constraints, such as limited supplies and time.
The activity emphasizes the change from potential energy to kinetic energy of the devices and their contents, and the energy transfer that occurs on impact.
The safe and accurate delivery of life-sustaining supplies to disaster relief efforts and military support locations in an unpredictable real-world design challenge. Using limited supplies in an egg to represent perishable supplies, we design and create and tested devices in an effort to investigate problems associated with supply delivery in remote regions. We mimic the process engineers use when designing the devices in airdrop supplies.
Solar oven. In this project, we define a simple design problem reflecting a need or a want that includes specified criteria for success and constraints on materials, time, or cost. Specifically, we learn about using renewable energy from the sun for heating and cooking as we build and compare the performance of 6 solar cooker designs. We explore the concepts of insulation, reflection, absorption, conduction, and convection.
Like engineers, we try to help people in remote areas and developing countries by designing alternate methods to fossil fuels and electricity for heating, cooking, obtaining fresh water, and sanitation.
Solar energy is often suitable, available, inexpensive. Renewable energy resource to power these technologies.
Like engineers, we study the position of the sun and the area's climate to optimize the amount of solar energy that can be collected at a given location. We also conduct research to determine the best available local materials that can be used to store solar energy and size the solar technologies to adequately meet the community's expected needs. Birdhouse design. This activity illustrates the interrelationship between science and engineering in the context of extinction prevention. Specifically, we have the challenge to protect a rare bird from extinction. There are two parts to the activity.
The first part challenges we follow the scientific process as we generate reports on endangered species and give a presentation worthy of a news challenge or radio broadcast. Scientific studies of endangered species can explain to engineers why a species is threatened.
The second part puts students in the shoes of engineers, designing ways to help the endangered species. Engineers use this information to come up with ideas for products that can help save species. Many projects that environmental engineers work on to help save endangered groups indirectly by helping preserve or restore their habitats.
One solution we have come up with is to design and build a birdhouse to provide a new habitat to our bird and keep it safe from predators. This is our birdhouses that we've created.
In this project, we create tetrahedral kites capable of flying. From our science lessons on gravity, we are designing a tetrahedron to use wind energy to combat gravity and create lift.
We explored different tetrahedron kite designs, learned that the geometry of the tetrahedron shape lends itself well to kites and wings because of its advantageous strength to weight ratio.
We design our own kites using drinking straws, strings, lightweight paper, plastic, and glue, and tape.
We experience the full engineering design cycle as if we are astronautical engineers. We determine the project constraints, research the problem, brainstorm ideas, select a promising design, then build a prototype. Then we test and redesign to achieve a successful flying kite.
In this project, we work as communications engineers. We particularly focus on sound and create technology to transmit sound long distances with a little loss in clarity.
We investigate how sound travels through string and air. First, we analyze sound waves with a paper cup attached to a string. Then we combine the string and cup with a partner to model a string telephone.
Finally, we undertake a design challenge to redesign the string telephone for distance. Hello, can you hear me? Yes, I can hear you. I'm in STEAM Lab.
We are building a pinhole camera.
In this activity, we will build a pinhole camera to observe the behavior of light.
Optical engineers need to understand how light rays work in order to design and create devices such as cameras, lasers, and fiber optics.
Perform. In this project, we relate science to engineering as we examine properties of sound and apply this knowledge in order to design a soundproof room.
Our challenge is to design a room that will absorb the most amount of sound so that the music does not disturb our neighbors.
We use a box as a proxy for the room needed to create a design that will decrease the sound that is coming from the outside of the box.
To evaluate this challenge, we use a speaker within the box and a decibel meter outside the box to measure the effectiveness of our design.
Today we're going to be showing you how to program and drive an EV3 robot, which is this robot right here.
The first step is to get to know the menu.
The second step will be how to build the body of the EV3 robot.
The
This is the palette, this is the canvas, and this is the dashboard. And these are the menus we will be using to program the EV3 robot.
So to create the code, you're going to want to drag one of the pieces to the canvas and connect it to the play button.
For the EV3 robot to be connected to the computer, you have to plug this cord into the EV3 robot.
Let's go.
Now that we have connected everything and created the code, we have to download everything into the robot.
Very good.
I'm going to download the code, and you will hear the beep that the code has been downloaded.
So here we have programmed the bots to go around this map and to start right here and to end right here where it started. And
wait.
We have assigned the values to the robot, and now the robot will drive around this map.
If the values are correct, the robot will go around the map, and if they are incorrect, we will change the values.
so now we are going to test the robot to see if it can go around the map. And
we're going to test it again to make sure all the values are correct.
Now we are going to be doing everything to make sure the last part is precise.
In this project, our challenge is to build a marble run. Everything is color-coded. We must select the correct item and
Why is it?
How is it like this? Because it's like that.
Oh!